Hello and welcome to this webinar in the NextGEOSS webinar series. I hope you all have had a wonderful summer. Some of you might have been in the ocean, and the ocean is the topic of today. My name is Bente Lilja. I'm going to be your host today, and as usual, I have a panel of experts that will teach us and introduce us to some interesting topics. Now, may I ask my panel to reveal their existence here? Here's Simon, Georgios, Lőrinc, and Arne-Jørgen. You will get to know them more shortly. The program today is 4 presentations and a Q&A at the end. We will get an overview of the ODYSSEA Project, a Horizon 2020 project. Then we will get to know the Marinomica platform. For those of you who entered the room a little bit early, you will have seen a very short video. You will see it again. If you missed it, don't worry, you will see it again. A very short introduction to the Marinomica platform. Then we will see some ODYSSEA services and products. And finally, we'll link all of this, the ODYSSEA, Marinomica with NextGEOSS, and even beyond that on the horizon, on the European and the global scene.
Yes, hello, I'm Georgios. I'm a professor of oceanography in Democritus University of Thrace in northern Greece, a university which is based in northern Greece, very close to the borders with Bulgaria and Turkey. I teach in several undergraduate and postgraduate courses. Over the years, I have participated in around 40 research projects funded by EU and the national funds.
Okay, let us hear what ODYSSEA is. And we will turn, the rest of us will turn off our cameras, but return when Georgios has presented. The floor is yours.
Shall I start my presentation?
Yes, please.
Okay, thank you. I hope you can see my presentation.
Yes, perfect.
Okay. So, hello. As I said, I will give you an overview of the ODYSSEA project. I would like to thank NextGEOSS and the GEOSS community for allowing us to give this presentation and show the activities, the achievements, and the challenges ahead of us within this the framework of ODYSSEA project. ODYSSEA is funded by Horizon 2020. So what is ODYSSEA? ODYSSEA is a user-centered project, an initiative which aims to make the Mediterranean marine data easily accessible to a multitude of a broad spectrum of end users and stakeholders. And we try to do this by harmonize the existing Earth observing systems, the data of existing Earth observing systems, for example, by providing this data through a unique platform, the Marinomica platform, that we will speak more on this later, by upgrading the existing operational oceanographic capacities, supporting the EU policy implementation, improving the interoperability in monitoring. We develop our own sensors and systems to monitor, and we try to foster blue growth jobs creation and open the participation to non-EU member states. So in fact, in ODYSSEA, we have partners from non-EU members of the Mediterranean Sea. For example, we have partners from Morocco, from Algeria, from Tunisia, from Egypt, Israel, and Turkey. So the main pillars of the projects are these. The main output of this project is a unique platform, a novel and easy-to-use system, which integrates, aggregates, and presents data from existing systems. We also develop our own sensors, our own systems to monitor the sea, and we develop systems that are easy to plug and play with different sensors, especially for the measurement of emerging pollutants like microplastics. We develop a series of numerical models which are coupled, and they are linked and they run operationally, and they downscale the existing models and the data that are provided by databases like Copernicus. And we are testing the usability of existing tools and interfaces like AquaSafe and DelfFuse in order to provide a task manager for all these models. We develop well-defined products and services to the end users, and we are testing the capacity of modern algorithms and tools like big data analysis, using artificial intelligence or machine learning in order to link the various data and to give the services to the users. So this is the main overview, the slide that gives you a brief idea what ODYSSEA is about. As you can see on the top of this figure, you can see the different data providers, the satellites, the existing databases, the sensors, the models, and all these are fed to the ODYSSEA, the Marinomica platform. But on top of that, we have the data from the ODYSSEA observatories, where we have a series of intense monitoring and modeling activities. And as you can see, at the end of the day, these data are post-processed, assimilated with the sensors, and finally, the end users receive this data according to their demand. So this is a brief overview of the Marinomica platform, the platform we developed in ODYSSEA Project. As you can see, it's very simple to use. You select the data set and the provider of this data, and then you can very simply and easily make these very nice maps. And also you can create time series by clicking a specific point, or have some statistics out of the diagrams and the selected data sets. We focus our activities in 9 areas, 9 pilot areas. These are called observatories, and we are doing this in order to fill in the data gaps, especially along the North African and Middle East coastline. So in parallel, we increase the spatial and temporal resolution of existing datasets, like those provided by Copernicus, as I said earlier. You see here the pilot areas in North Aegean, the Thracian Sea, the Gulf of Kosovo, the Valencia coastline, Northern Adriatic, the Arjubain Storal Gulf in Algeria, the Gabes Gulf in Tunisia, the Al Hoceima National Park of marine protected area in Morocco, the coastline of Israel, and the whole coastline of Egypt, where is the influence of the Nile. What is now an observatory? For us, an observatory is an area where we have a local partner, a local ODYSSEA partner who is responsible to run ODYSSEA activities, but also to provide the trained staff in order to run the numerical models, to have the trained staff to use and maintain the sensors we deploy, but also to identify and contact the potential end users, the stakeholders that need marine data, to promote the use of the platform, and to customize the dashboard of the Marinomica platform, a tool that gives the users the capacity to have personalized information on marine and maritime data. These are the models. As you can see, an overview of the various models. We are applying a series of numerical models for the whole 9 areas. As you can see, we run hydrodynamic models, wave models, biogeochemical, also oil spill models on this right-hand side, and here, these are ecotrophic models that we run for to understand the web, the trophic web in each area. In terms of monitoring, we have 2 types of systems, the mobile and the fixed ones. In terms of the mobile systems, we are working mostly with gliders. The gliders we developed, these are the 2 systems, 2 Sea Explorer gliders developed by Al-Seamar. We use 3 different sensor payloads. The first one, which is a standardized payload with CTD data. The second one, which is for the monitoring of marine mammals, passive acoustic monitoring. And the third one, where we have the microplastic sensor. The microplastic sensor was miniaturized and was designed and encompassed on top of this glider, so that we have the capacity really to measure microplastics as the glider moves forward within the water column. Our work shows that, and our tests give us very good results, but after a certain depth, the sensor has malfunctioning due to the increased pressure, and this is something that we are considering, and we are trying to redesign the sensor. In terms of fixed systems, we have these surface buoys that are moored, and they are deployed in very close to the facilities of the various Mediterranean users. And we have these deep systems, which are the benthic systems that we develop, and they are deployed in very deep waters. Here you see a deployment very close to an oil rig at a depth of 60 meters, but we can go even deeper, up to 1,000 meters. And this is the microplastic sensor and the microplastic pack as it has included in the system. So in terms of analysis and of Earth observation data, we started by analyzing the data gaps that exist in the Mediterranean Sea. So we have reviewed the various platforms and the existing systems and the data providers. And if you wish to have more information on this, you can check this publication in Science of the Total Environment. In terms of customized models, we collaborated with the Valencia Port authorities for the modeling of the jellyfish in specific areas. Specifically here, this is the area of the Valencia coastline. This is the work done by Deltares group, and if you wish to have more information on this, this is the work they have published in ecological modeling. In terms of understanding the and valuing and assessing the trophic web and the fishery indicators in specific areas, we have worked extensively by using the EcoPath model, which is a model, the most appropriate model for this type of work. And as you can see, we have developed a series of indicators for catch, for trophic web, for the balance in fisheries, the ecological indicators, and the overall assessment, and more information can be extracted from this paper. We apply AI and machine learning tools for the species distribution models. We started by working with the fish data from FishBase, the FAO FishBase. As you can see, it's a very coarse database with a lot of gaps. And after the implementation of machine learning, by considering all the data from Copernicus, and IMODNET, we tried really, and we achieved to increase the resolution down to the level of Copernicus grid cells, and to also have, in this diagram, you can see we don't have any data gaps, so we don't have any data gaps in the species distribution models. More you can see this in this paper, and we do more or less the same work for the benthic species. As you see here, we have the seagrass habitat preferences, again by applying machine learning tools, and the impact of climate change. So we have a species distribution maps of the different seagrass species over the Mediterranean Sea. This map was provided by FAO, and we again utilize the wealth of data from Copernicus and IMODNET in order to see the preferences and the impact of climate change on the distribution of species. We use the glider data to reveal the water column dynamics in specific areas. As we have, for the moment, we have deployed the glider in 3 missions in the Thracian Sea in North Aegean. We have implemented 2 missions in the Alboran Sea in the Morocco Observatory. Now we are carrying out a mission in Tunisia, from Tunisia to Malta, in association with the University of Malta. And we intend to finish the project with 2 more missions, one in Israel and another one in Tunisia again. And we don't only do that, but we are trying to calibrate the Copernicus data, the data from Sentinel-3, with the data that are recorded by the gliders, the chlorophyll data, over the euphotic layer. In terms of coastal erosion, we use the Sentinel and Landsat satellite images in order to assess the hotspots of coastal erosion. And as you can see, we have done this in the whole of the 9 observatories of ODYSSEA, and there are areas where we have significant issues in relation to the evolution and the change of the coastline over the years. Another work that we have done is the wind resource assessments. There is a growing interest of many companies to invest in the wind turbines and wind farms over the Mediterranean Sea. So we have developed a methodology on how to assess the wind resources using the scatterometer data from Copernicus, again, with a resolution of 0.25 degrees. And all this data and all these methods can be found in these two works. We also employ machine learning tools in order to forecast and predict in the short term and long term the wind resources in specific areas. We organize workshops with our users in association with several initiatives and projects over the Mediterranean Sea. We organize every year a summer school for the students and young scientists to learn about Earth observing data and to use the Marinomica platform. And we train students and young scientists on the use of the Marinomica platform, especially focusing our efforts in the Northern Africa countries and the Middle East. For example, here you see the various training activities in Algeria, in Morocco, and in Tunisia. Thank you very much. This was a brief overview of the project. Thank you.
Hi, good morning, everybody, or afternoon, or depends on where you are. I've just realized that I'm wearing exactly the same glasses as Georgios, but I can assure you that there's a different person behind the glasses. My name is Simon Keeble. I'm a software engineer. I'm also the technical director of an SME in the UK called Blue Lobster. We specialize in the development of software solutions, mostly web and mobile applications, in and around the marine, aquatic, and environmental sciences, or certainly with a strong bias in that direction. And we also are quite engaged in communications and marketing for a number of projects. In the ODYSSEA Project, we are the work package leaders for communication and outreach, and we've also been responsible for the front-end development of the Marinomica website and application. But I hasten to add that there are a lot of people and different partners involved in the development of Marinomica. So we didn't do it in isolation. There are many other people out there that have been involved in this. So hopefully that gives you a little bit about me. I'm going to try and share my screen with you and give you a little bit of an overview of Marinomica itself. Perhaps if someone could tell me if they can see it, that would be good.
We see your screen.
Wonderful. Okay. So I'm sure you're going to hear the word Marinomica a lot. I encourage you to go to the application or the website and read a little bit more about it. It's an evolving project. We haven't completed it yet. So the application is still in development. New data are coming online, new facilities. But on the website, you should get an overview of the type of thing that we're trying to do with the application. And this involves looking at jellyfish forecasts, ocean energy, maritime safety, aquaculture, fisheries, plastics. Georgios mentioned that we've got a plastic sensor that we've been working with. Leisure and tourism and coastal erosion models are coming online very, very shortly. So there's quite a wide-ranging field, and it's not exhaustive. There are other products that are coming online over the coming months. So this is the main screen of the application. I've resisted the temptation to do a live demonstration because they always go interestingly. And I'll just talk you through some of the features of it, and then hopefully you can have a look yourselves and discover a bit more about it. So the left-hand side of the screen, you can see that there are various parameters that you can investigate and explore. A little bit lower down, we have some of the products that we produced specifically as part of the ODYSSEA project. These were forecasts, but I did take these screenshots in middle of July. But the idea is that you can use this to forecast and also to have alerts to tell you when things are coming. This is a wave power product that we produced as part of ODYSSEA. The plots, you can drill down into them a bit more. You can smooth curves out. And you can have some interactivity. You can zoom and pinch and all those sort of interactive features that you would like to have. This is another product, which is Tricks, which related to eutrophication. I'm not going to pretend to be the scientist here. I'm a software developer that are working with models that have been produced by the scientific teams. And in here again, you can see the interaction with the maps. You can move around it and get further information from it. One of the key features that we have in the application is the dashboard. We have the ability to create lots of different dashboards to do lots of different things. We can create them as a consortium, and we can share them with the public, and they can copy them into their own areas, or other people can create their own dashboards. Each widget or part of the dashboard can be shared inside this or externally. So you can embed these maps and plots into other applications outside of here. And you can also put in narrative. In this case, at the bottom, that you can see an example of narrative in there. It's just dummy text, but it's HTML. So we can embed HTML and JavaScript and all sorts of different things in there as well, so that we can put videos in there and other products and services from outside of the application to complete the whole dashboard. We have time series data. These are tidal gauges where you can view that data. Here is a tidal gauge just off of Italy. It's a little bit old data here. I've picked this at random, but it's slightly old data from 2019. But you can see that that's actual in situ data. Another product that we produced as part of ODYSSEA around Morocco. This is again a sort of a plot that you can look at map data, but you can also download that data as well. So we have a full download suite available to us. You can fill it in manually, or you can draw a box around the area that you want to download data for, and select the parameters and features that you want to get the data. It will download that to you, generally in a .NET-CDF file if it's spatial data such as from a map, but other formats are available depending on what the data originates as. We can also layer maps on top of each other, so we have a hierarchy. In this case, we have a visual map, but on top we have arrows that give an indication of velocity. In this case, it's seawater. And in addition to that, we have the ability to view the time series data that is in an area. So you can look at maps, you can look at velocity, and you can look at the in situ data at the same time to see what's going on. So it allows you to look at many different layers together. New projects that are coming on. EcoScope is a project that starts, I'm just looking at my watch, it's the day after tomorrow. It starts on the 1st of September, that looks at a toolbox that is available using this and other tools. It's not just Marinomica, but other tools to provide, as it says here, to promote an efficient ecosystem-based approach to management of fisheries. The Marinomica platform is very much in the realms of being able to provide digital twins. There's a lot of buzz and talk about digital twins at the moment. In the UK, where I'm from, our government are very, very big on this at the moment. So it's good that Marinomica and other products will be combining themselves into providing significant digital twins, and we'll announce those over the next few weeks and months as to what we're planning to do. And we're also in some good conversations at the moment in how to commercialize or monetize the platform with industry and different sectors, so that we can see if we can find a good, sustainable future for it that is outside of the, I guess, the standard funding model for these things. So that's progressing quite well as well. So very, very short introduction to it. I do ask you to go to marinomica.com. Let me know if you have any problems or if you have any questions. As I say, it's a beta stage at the moment, but we still have a little bit of time left to run on the project, and things will change over the next few weeks and months as we get towards the end, but also significantly ramp up in the development as EcoScope and next projects come along. So it's got a long-term future. We have a native mobile app. It says shortly on there. I've actually got it. It's a national holiday today in the UK, but tomorrow when I get back, this is one of the first tasks I've got to do, is to do some robust testing on our native mobile app and get that into the App Store and Play Store for Google. So please look out for that over the coming weeks and months as well. I think that'll be a useful tool, particularly later on when we look at alerts under certain conditions. Thank you very much.
The OECD forecasts that by 2030, ocean-based industries will employ more than 40 million people worldwide. Today, 80% of global trade is carried by sea. This illustrates the importance of gathering all the available data on the marine and coastal environments. Marinomica provides on-demand derived data services, in particular forecasts, to a wide range of users managing and mitigating challenges and exploiting opportunities arising from the sea. The platform is a one-stop shop offering its services to all parties engaged in sea-based activities. The innovative platform is an excellent tool for mitigating pollution hazards, untreated waste, and more. Marinomica addresses the needs of offshore maritime, renewable energy, fisheries and aquaculture, tourism, oil and gas exploration, shipping, and ports. The platform provides data including historical and real-time data and forecasting that provide critical seawater quality parameters, based on Earth observation monitoring data systems, like satellites and in situ sensors and data. Marinomica is ideal for identifying coastal erosion, hotspots in specific areas along the shoreline and obtain forecasts about potential coastal retreat and loss of land. The all-in-one system provides you with a complete picture of current and future parameters in its full situational context to fine-tune operational and business planning, increasing revenue and reducing costs. For more information, visit www.marinomica.com.
I'm Lőrinc Mészáros from Deltares, and I'm specifically from the Marine and Coastal units and Data Science and Water Quality Department, which quite nicely describes what we are doing in this project, deriving marine and coastal services, and using data science tools, all kind of monitoring technologies, a lot of Earth observation, and trying to package this into nice services to all kind of users. And this is what I've been working on in a range of other European or national finance projects. And within the project, the ODYSSEA project itself, I'm mainly trying to help to navigate between the scientist perspective that was also presented by Georgios, all those intellectual innovations, and also the user needs that were evaluated and collected along the project. So again, we are talking about the ODYSSEA project and the services and products that we are delivering and producing. And because it is available through the Marinomica platform, we often call it the Marinomica services and products, but this is all under the ODYSSEA project. So just to summarize in a really quick message, what we are trying to achieve is user-friendly products that can be used not only by trained professionals, but also untrained either NGOs, scientists, decision makers. It is really about trying to deliver information that is actionable and easy to interpret. So stepping back and summarizing all that basically Georgios was outlining, that is that we have, from the technological perspective, a range of data sources, all those in situ, the coastal models that operationally being run, all the external data sets. We touched a bit about the citizen science. We have to update because it's continuously changing, and a bit of this machine learning and algorithms that can combine and enhance the data. And this gives us a range of essential ocean variables or non-essential ocean variables, but a range of marine variables. But when we talk about services and products, we have to package this into a more understandable way, and we have to focus on the problem itself, how to deliver really tailored information. So for this, we had all along the project consultations with users. On the platform itself, we have a profile section where you can fill your country of interest and also your sector. And later on along the project, we are going to connect those identified sectors to the dedicated dashboard, so that when you launch your platform, you don't have to go through all the selection of variables, but it will be something really customized for you. So keeping this in mind, now we can look back to the table and reorganize a bit. And I highlighted tailored here because that's the most important part. We as users, we don't necessarily want to know where the data is coming from, what kind of manipulation steps have taken place. What we are really interested in is the application domain, be it offshore, oil and gas, ecosystems, ports, or aquaculture, and what exactly we can extract from this information. And this is if we consider adverse events, for example, location, the time when it's happening, can we get alarms, early warnings, and other information attributes that are really relevant and helpful for decision making. So this is the tailored part of our services. The second part is the coastal, which was already highlighted by Georgios, that there are still plenty of environmentally and or economically important areas along the Mediterranean basin. And they are not really, they are not sufficiently covered by global regional data. And we have to focus separately on those, and we can, using the ODYSSEA approach, plug in new models and solve the sufficient scales for coastal modeling. So this was all about how we derive the data to make available services. And now from the user perspective, what you get is essentially a theme that you would like to explore, be it maritime safety, really industry oriented, such as port or aquaculture, more policy oriented, related to plastics, as it was mentioned by both speakers. And here, what we present is really the information attributes. So how it is being developed and how it is being collected, it's in the background, in the backend. What's really important for users is these information attributes. And as Simon outlined, the best tool that we have at the moment to really deliver tailored services are these dedicated dashboards that can be customized by us in advance or by the user themselves. And these are usually focusing on a specific geographic area where the users operate. They are focusing on a topic of interest, in this case, the eutrophication. And then, apart from giving background information in HTML and adding images, links, then you can select the indicators from the platform and add to that dashboard in a way that you find most useful. It can be alerts, it can be time series or maps. And the whole idea is then that you have everything that you need for your operation in one specific dashboard. So this is about the main concepts, and I just end the presentation with a few examples of the visual representation of our services. Some of them were mentioned, for example, the wave power. I put in brackets where they originate from if the audience is interested. This is being calculated by our own algorithms and gives the wave energy that is potentially useful for offshore operations. Another interesting one, more on the water quality domain, is the trophic status. That is mostly useful for the policy domain, but there is also interest now in aquaculture or any other operational systems that would like to know the traffic status of the waters. This is also calculated by algorithms. Another interesting example is the power of our coastal models. This is nutrient concentration along Morocco. And what you see is that the scale, when you increase, then it even allows you to investigate land-based source events. And that is something that is add-on from the openly available existing data sets. Yet another one is the lander that was already described by Georgios. These, of course, these ODYSSEA measured data sets are available through the platform, and you can derive the statistics out of them. You can visualize them, export, and further process if it's needed. And the last, because it was already asked by the audience, the jellyfish occurrence. The jellyfish portfolio itself, as Simon mentioned, it includes our own ODYSSEA developed distribution model, which means that you release the jellyfish particles, and with their biological stages, they develop, evolve, being spread, and then if it's red, then they are stranded, and the coastal authorities can be warned. But of course, there is the semantic analysis of the social media accounts or the more curated citizen science. So I thought that this would give you a bird's eye view of the Marinomica process of deriving the services and some of them that are already available. But of course, if you have more questions, please contact us, me, and post your questions right now.
Yes, my name is Arne-Jørgen from Sintef Digital in Oslo, Norway. I have a focus on digital platforms and interoperability in different domains, work with the European organizations like Big Data Value Association and the new AI Data Robotics Association. And in this context, there is a lot of interesting technologies that can apply. In particular, the area of digital twins is relevant. Also, you might have heard about the initiative of the Commission on Destination Earth. So that is an interesting context for not only the ocean, but also other aspects of Earth modeling. The ILIAD project that we will talk about is funded through the European Green Deal call. That was last year and is now starting towards the end of this year. And it's part of a very ambitious vision of creating high precision digital models of the Earth. And that means that the digital twin of the ocean is an important part of this. But there will also be others, and they will have to be integrated and related. And it's a huge vision by the European initiatives for the next 10 years. So in particular, we have been involved now with ODYSSEA Project and Marinomica, as you have heard, also NextGEOSS in the context of this call, for a project funded for this digital twin of the ocean called ILIAD that will start towards the end of the year. What we see here is basically the life cycle of data collection for a twin, from the initial data collection to data management, to hybrid models, fusion models, visualization, and analytics. And a number of initiatives and platforms that are related here. We don't believe in one digital twin of the ocean. We believe in the twin of twins approach. And for that, we are creating a federated architecture that allows a number of initiatives to be brought together. So we see a lot of various sources of data input on the left-hand side for data acquisition. ODYSSEA is one of them. We have Ocean Labs in Norway, in the North Sea, and many other places that will be brought in. We have the DISSES, Copernicus. There is a lot of data sources, and they also come together with models. So there are also models as part of this input. And our approach here is to bring together these in a federated system where NextGEOSS provides input on a federated catalog. We have just heard about the Marinomica underlying platform, but we are also using others such as the Ocean Data Platform. We take inspiration from an interoperability space from agriculture called Demeter, working with the standards, and also in the large European initiative of European data spaces with Gaia-X and the International Data Spaces Architecture, again linked to computing and storage resources, integration of models and model fusion. Of course, this is all spatial temporal models that needs to be harmonized in space and time to work together and to interoperate at different resolution levels. So there are integrations here that are needed for this to happen as a kind of unified perspective into a lot of different data sources and models, with associated user interfaces, dashboards, and interaction environments. And of course, for this, we have a number of different application areas. We heard some of them today, and there are others. It includes also citizen science, besides the sensor technologies, and various architectural approaches, including the Gaia-X, the International Data Spaces Association, the Federation of NextGEOSS that goes into the ILIAD architecture. Some of you might have seen this model here from Gaia-X and from IDS, annotated with aspects of the NextGEOSS Data Hub, federated catalogs and identity management, the notion of data spaces, which will go beyond the digital twin of the ocean, but also to other domains of European data spaces, and be part of the international data spaces. But in particular, in ILIAD, we will focus on the digital twin of the ocean in this context to bring both data and models together. So this project is now in, say, negotiation contract setup phase and hasn't started yet. Of course, there are more details to all of these architected things that we will come back to. But as you see from some of the platforms here, the ODYSSEA Project and Marinomica are important core partners in this, as well as NextGEOSS and others. So this is a kind of pre-marketing of the things that will come from this project once it gets started, even though we are already working on it now, even before the project has officially had its start. So that was a quick overview and the context of ILIAD related to the presentations you heard today.